Good morning, I am Mr. Ish. Thank you for joining me for this video. We have a single question over here, a interesting question, perhaps a difficult derivative application question, you might want to call it that. We have to find the 1000th derivative of that function x times e to the power of minus x. It's a product of two separate functions, and if you have to find the derivative but you have to find the 1000th derivative, it would make sense to do extrapolation over here. Find a couple of derivatives and extrapolate what that 1000th derivative would be, because everything here would repeat with regards to a cyclical pattern, or a cyclical pattern if you want to say that. And you would start here by doing the first derivative. You know you have a product of functions here, so you want to use a product rule. What we can do here is probably go up to 4 cycles of derivatives and we can extrapolate that 1000th. You know you'll use a product rule. You'll have e to the minus x times the derivative of x plus x times the derivative of this e to the minus x, which here is our g function. This is my f function, that's the g function. And you know these functions are easy with regards to their derivatives. This becomes e to the minus x, and that becomes minus x e to the minus x. Why is that? Because the derivative of e to the minus x would follow the derivative scheme of this e to the ax, which is always a e to the ax. Here a just happens to be a minus 1, so you end up getting that. So you get e to the power of minus x e to the minus x. That represents our value, our first derivative. That will feed in now as our second input for the second cycle. So we should do that. We'll do the derivative of that, and let's do it. It shouldn't be too hard. We have minus x e to the minus x over here. You know the derivative of e to the minus x is easy. You can just do minus e to the minus x. Now you have a product rule over here, and I can just bring a minus and I can do the derivative here, the product rule f and the g function. I'll do the g function times the derivative of the f function plus the f function times the derivative of the g function. And what I want to do is work it out here and then put a final answer over there. I'll have minus e to the minus x. Here I'll have e to the minus x. Here I'll have minus x e to the minus x. Then of course I have to open up all of this. I'll have minus e to the minus x minus e to the minus x plus x e to the minus x. I can combine this. I'll have minus 2e to the minus x plus x e to the minus x. This right here I want to just put over here, and then we can maintain a certain level of neatness over here. Minus 2e to the minus x plus x e to the minus x. That's my second derivative, which will now have to input into the third cycle. Now we're doing the derivative number 3, the third step, and we're doing the derivative of what we see over there. I believe when we have 4 done, we can easily extrapolate that 1000th. We have minus 2e to the minus x plus x e to the minus x. When we do this, the derivative of this is easy. It's no product of two functions. You can just do easily by your template that you know. It'll become 2e to the minus x. This minus 1 will multiply with this minus 2. You'll get 2e to the minus x. Anyhow, we have a plus sign. Now we have to do our product rule for this part right here. We'll have e to the minus x times derivative of x plus x times the derivative of e to the minus x. Some of you can probably do most of this in your head and do it much quicker than I'm doing it. Here we'll have e to the minus x. Here we'll have, you know what? Here we'll have a minus x e to the minus x. Accumulate everything here, and what do we end up getting over here? We end up getting here 3e to the minus x e to the minus x. You can't do much with this, so we'll just put it over here. 3e to the minus x e to the minus x. And that right there is my third derivative outcome. Let's do the fourth. I think maybe at 4th we should be good. We'll do the derivative of everything we see over there. We have here 3e to the minus x e to the minus x. The derivative of this is not going to be hard. It'll just be minus 3e to the minus x. Derivative of this, well, you have to do the product rule, and let's probably just make it clean over here. We'll have e to the minus x times derivative of x plus x times the derivative of e to the minus x. And then we have to compute all of this. We'll have minus 3e to the minus x, right? We'll have from here minus e to the minus x. This will become a minus x e to the minus x, which will hit with this minus. You get plus x e to the minus x. When you combine all of this, you're getting a minus 4e to the minus x plus x e to the minus x. And that's what I'm getting, minus 4e to the minus x plus x e to the minus x. And when I'm looking at all of this, I'm seeing a pattern come about. I know everything is here with regards to this first part increasing by a coefficient of 1. It's 1, 2, 3, 4, it's linear, but then you always have an alternation here of signs, positive, minus, positive, minus. With regards to this term here, it's always x e to the minus x with only the signs changing. The 1000th term would be the fourth term here cycling 250 times, because 1000 divided by 4, right? 1000 divided by 4 is 250 cycles. So the fourth term would very well mirror the 1000th term. You can just do minus 1000 over here, e to the minus x, and of course you'll still have this here plus x e to the minus x. And why would that be the case? Because if you did by 4, 8, 12, 16, 20 and you keep doing this, by the time you hit the 250th cycle, that would represent your 1000th term, which would very well mirror what you see exactly here. And your 1000th derivative would be this. Everything here is exactly the same. You have a positive x e to the minus x. You have e to the minus x. The only thing that changes here is this coefficient, which would be minus 1000. And that right there would be your answer. And your question has been solved. Thank you for watching. Stay tuned. Have a nice day.